Good day and welcome. Today we're going to do section 2.2, which is subsets. In section 2.1, we talked about the very basics of a set. We talked about a lot of notation, what it meant, a lot of vocabulary, and we're going to get some more of this here. We have the definition of a subset, where it says set A is a subset of set B, which is expressed like this: A is a subset of B. Now that symbol right there is almost like less than or equal to, but that is rounded and not pointed. And they have kind of the same meaning if you look at it from the right direction, okay? Set A is a subset of B if every element of set A is also an element of set B. So if we were going to show this using a Venn diagram, this could be set B, and then set A would be entirely inside of it. Okay? That means everything inside A is also inside B. Okay? Now, if it's not a subset, if A is not fully enclosed inside B, then it's not a subset and we just draw the line through it. Okay? Now, there is a note here. Every set is a subset of itself. So I could have set B here and then technically draw another circle over it, also label it set B, and they would be a subset. If you're thinking about this as less than or equal to, you know, if we were allowed to do 3 is less than or equal to 3. You're allowed to be the same things on both sides. It's kind of the same thing here. You could have set B as a subset of set B because you can think of that like an equal to right there. Okay, so let's look at some example problems. What we have here is we're supposed to find whether these are subsets or not. Okay, now what we're going to do is we're going to look over here, and if everything inside here is also inside here, then it is a subset. If there's anything here that is not over here, it's not a subset. Okay, so right here, I have a 2, here's a 2, 3 is here, 7 is here. Everything in here is also in here, so this is a subset, and we would enter that symbol. Okay, now going on here, I have -4, and I have -4. I have 0, and look, there's no 0 over here. Now the 4 is there, but I do have one thing in this first set that is not over here, so it is not a subset. Just put the line through it. Okay. Now here's one that is written in set builder notation, and this one requires that we use our general knowledge. This is the set of all x's where x is a dog. So this is the set of all dogs. And this x, the set of all x such that x is a purebred dog. So here we have all the purebred dogs. Here we have all the dogs. And we need to decide whether they are a subset. Now, do I have dogs that are not purebred dogs? Well, of course. So there are dogs inside this set that includes all the dogs that are not purebred, so they're not over here. So this would not be a subset. Okay? Now, if this were reversed, and I had purebred dog being a subset of a dog, that would work. That's true. Okay, so let's look at this one. And they very nicely give us a word here, and not so much over here. What we just need to do is to make sure that everything is here is also over here. So I'm going to start marking them as I see them. R is here, E, V, O, L, U, T, I, O, N. Everything here is also in here. Now it turns out that these are exactly the same. So this is that special case where every set is a subset of itself. So your answer here is that it is a subset. Okay, now just like where we have less than or equal to, we also have just less than. And we're going to have that same basic idea here with proper subsets and not proper subsets. Okay? Set A is a proper subset of set B, which is written like this, and notice it doesn't have the little equal to part on it. If set A is a subset of B and the two sets are not equal. Okay, so if we look at this one right here, it is a subset, but these two are equal. They contain exactly the same elements. So this one would not be a proper subset. A lot of times when you do have a subset, you also have a proper subset. It can be both, but there are cases where you can be a subset but not proper. Okay, so let's look at another little bit. The empty set, which is also called the null set, is a subset of every single set, except, well, it is even a subset of itself even. So remember, the empty set can also be written with braces like that with nothing between them. This is how it shows up on the homework. This is what you're more likely to see in a book or generally when people are talking, but they mean the same thing as the empty set. So it is a subset because everything in the empty set, which is nothing, is also in B. Okay, well, I should rephrase that. There's nothing inside here that is not in B. Now, for any set B other than the empty set, then the empty set is a proper subset of B. Because it can't be the empty set, because that would mean we'd have the empty set equal to the empty set, which does not allow for it to be proper. Okay? So let's look at some example problems. And we are asked to decide whether we can put subset, proper subset, both, or neither in each of these. Okay. So we have the empty set, and we have 1, 3, 5. We've just said that the empty set is a subset of every set, so I can definitely put that. But can I also put the proper subset? Yes, because these two are not the same thing. Okay, so what we've got is this one can be both because it is a subset and it's also a proper subset. This would be analogous to the case where you can use a less than or less than or equal to in it, and it's still both true. Okay, so now here, it's basically reversed. Is 1, 3, 5 a subset of the empty set? Well, what we ask ourselves is there anything in here that is not in here? And the answer is yeah. All of these, 1, 3, and 5, none of them are in over here. So this is most definitely not a subset. And if it's not a regular subset, it's not a proper subset. Okay, so let's look here. We have the empty set and the empty set. Okay, so are these, is it a subset? Well, yeah, the empty set is a subset of everything. So it's definitely a subset, but is it a proper subset? No, because if B is anything other than the empty set, it's true, it is a proper subset. But we have two empty sets equal to each other, so this is the only one we can use. We cannot use the other one. Okay. The set VCR and VCRS. I have a V here and a V here. C is here, R is here. Everything that's in this set is also over here, so it is definitely a subset. Is it a proper subset? Yes, because this one has an S, this one doesn't. These are not equivalent. So I could use either one, so this answer would be both. All right, these two. 91734 13479. I think these are equivalent. I have 9. There's my 1, 7, 3, and 4. These are exactly the same. So since they are exactly the same, it cannot be a proper subset. But two sets that are equivalent are regular subsets. I can use this one, but not proper. Okay. The set of all men and the set of all women. And we are going to use traditional definitions of man and women, okay, for the purposes of these problems. X is a man, they're men who aren't women, right? Yeah. So can this be a subset of this? No. There are men who are not women. There are people in this set who are not in this set. So this is neither. I can't do anything with it. Okay. Now, if X is a woman and X is a person, is every woman also a person? Well, yes. So I can definitely have a subset. Can I have a proper subset? Well, yes, because there are people who are not women. So I could also use proper subset, so this answer would be both. Okay. Now here we've got two different, they've given us A and B, and they've defined them for us. And they want us to determine what we can put in here. This says A is a natural number between 3 and 10. And this is the set of natural numbers between 3 and 10. Well, I just said the same thing, right? These are exactly the same thing. This is just written out in English. This is written in set builder notation. And so that means A is equal to B, correct? All right. So if A equals B, then A is a subset of B, but because they are equal, they are not proper subsets. All right. Now, one of the things that becomes rather important is to know how many subsets and proper subsets you have, okay? And there's a pretty easy formula here. The number of distinct subsets of a set with n elements is 2 to the n power. The number of distinct proper subsets of a set with n elements is 2n minus 1. And the 2n, you don't have to understand where it comes from, but the minus 1 should make sense. And that's because the only difference is you're not allowed to be equal. So this will give us the number of subsets there are, including them being equal. And here we just subtract off that 1. Okay, so let's look here. Let's calculate the number of distinct subsets and then the number of distinct proper subsets for each one. All right, so if I have A, B, C, D, E, F, I have how many elements? A, B, C, D, F, I have 6 elements. So what that means is if I want the number of subsets, I need to figure out 2 to the 6th power and go to a calculator. 2 to the 6th power is 64. So I need to have, if I were to list all of the subsets, I would have 64 things listed. Now for proper subsets, we're going to take that 2 to the 6th and we're going to subtract 1 from it. So 64 minus 1, the answer would be 63. Okay. Now I'm going to do the same thing. How many subsets are there? If that we have the set of all X such that X is a US coin worth less than $1. So the first thing we have to do is to figure out all the coins that are less than $1. We have 1 cent. We have 5 cents, So a penny, a nickel, we have a dime, and then we have a quarter, and we have a 50-cent piece. That one's often forgotten, but you cannot forget this whenever you're working these problems. We do have 50-cent pieces. We don't see them very often, but they do still exist. Okay, so how many elements are there in here? It's 5. So my number of elements, I have 5 elements. So for the number of subsets, I figure 2 to the 5th power, which is 32. And then for proper, I'm going to have 32 minus 1, so there are 31 proper subsets. Okay, so let's look at some true and false. All right, this set listed in roster method, 1, 2, 3, assuming it goes up, and I'm going to put a comma in here so it's a little bit easier to see, it goes up to 10,000. So this set has 2 to the 10,000 proper subsets. Okay, well first, if this is my set, then my number of elements would be 10,000. Okay, and I know I do 2 to that power, but notice right here, it says proper subsets, not regular subsets. So this is not the answer. This is the number of regular subsets. The answer we really need to see is 2 to the 10,000 minus 1. That would be how many proper subsets. Okay, so now this is also true and false. We have the set of all x that is a natural number, where 30 is less than x is less than 50, and over here it's 30 is less than or equal to x, less than or equal to 50. Now the main difference here is if I were to list all of these out, I would start at 30, 31, and I'd go all the way up. No, I'd start at 31. Start at 31 because you're not allowed to equal 30. Start at 31, go all the way up, and you'd stop at 49 because it has to be less than 50. But here, you're allowed to equal. So on this one, I would start at 30, list 31, go up to 49, and then 50. Okay. Now this says it is a subset. Is everything here also in here? Yes. Okay, so this one was true. This one was false. Okay, now to get practice listing all of the subsets, list all the subsets and then list all the proper. Okay, so here we have a set with just 2 elements, Romeo and Juliet. So I'm going to do a quick calculation. I expect there to be 2 squared subsets, so 4 subsets. And I expect there to be 2 squared minus 1, which would be 3 proper subsets. Just doing that much can help you out because it can get easy to get lost in these problems. What I generally do is I start off with making my subsets as small as possible, and then I start building them up in size. You don't have to do it that way, but you really want to create a pattern that you generally stick to. Otherwise, you run the risk of missing something. And just for the sake of brevity, I'm just going to write R and J instead of writing out the whole name. Okay, so my first subset is always the empty set. That one has the least number of elements. Okay, it has 0 elements. Now we go up to 1 element. Well, I can do an R. Then I can do a J. And then I go up to 2 elements, which gives me the R and the J. Now I would keep pairing things up until I had all the possible pairs, and then I would move up to 3 elements, 4 elements, 5 elements, however many I needed to go to in order to list them all. So here I have 4 subsets, just like I expected. Now if I want proper subsets, this is the only one that goes away because this is actually equal to what we were doing. So you would basically list them again, but leave off the one that's exactly the same. Here we have 3 proper subsets, which is what we expected. Okay. Now here, this one has 3 elements, T, A, B. We're going to do the same thing. So I would have the empty set in both of them. Let's just do it this way. Okay, I can list these at the same time. So I have the empty set. Now I start going by just one. So this is, I have T, I have A, I have B by itself. All right, so I've used up all of the ones individually, so now I'm going to start pairing them up. I can do T and A. And then I can do TB. Okay, so I've used T both times. Now I'm going to pair up A and B. Okay, that's all the possibilities with 2 elements. Now I would go up to 3. But that's going to be exactly the same as here. So this one, regular subset, gets T, A, B, but the proper subset does not. So this would be if you listed them all out. Let's do the quick math with the formula to make sure we have the number we expected. So I have 3 elements, so I have 2 to the 3rd power. Let's try that again, which is 8. So I would expect 8 subsets here, 1, 2, 3, 4, 5, 6, 7, 8. And then the number proper should be 1 less than that, 2, 3, 4, 5, 6, 7, so it works out.